In this video, we'll get some practice using the compound interest formula where interest is compounded continuously to help us calculate various things like the future value and present value of an investment and the amount of time it takes to reach a certain amount of money. In our previous video, we learned that if interest is compounded continuously, then the compound interest formula is A equals P times e to the power of R times t, where A is the amount of money that we'll have after t years, which is also known as the future value, P is the principal, R is the annual interest rate, and t is the number of years we're interested in. I want to mention that in real life, banks do not offer interest compounded continuously. However, this new formula is still useful because it's easy to perform calculations with it, and it gives us good approximation of things when interest is compounded frequently. Also, this new formula has nice properties, but we won't get into it because it is outside of the scope of a pre-calculus course. So let's see how we can use this new compound interest formula in various scenarios. In our first example here, suppose that we invest $2,500 in a savings account that earns 2% annual interest compounded continuously. We want to know how much money will be in the account after 30 years. Let's start by writing down the quantities that we're given. We know that our principal is $2,500 because that's how much money we put into the account initially. Our annual interest rate R is going to be 2%. Written as a decimal, this is 0.02. And we're interested in how much money we'll have after 30 years, so our t value is 30. Since interest is compounded continuously, we're going to use our new compound interest formula, A equals P times e to the RT. Plugging in our values, we have A equals 2,500 times e raised to the power of 0.02 times 30. Plugging this into our calculators, we end up with $4,555.30 if we round to 2 decimal places. So if we invest $2,500 now into a savings account with a 2% annual interest rate, after 30 years, we'll have around $4,500. Let's consider some other scenarios. In this scenario, suppose that a certain bank offers a high-yield savings account that earns 4.5% annual interest compounded continuously. How much money do we have to invest now so that 25 years from now we'll have $50,000 in the account? In this problem, we have a goal of $50,000 in mind. And so what we want to do is figure out the present value of the investment, which is how much money we have to put in now so that 25 years from now we'll have $50,000 in our account. Again, we'll start by writing down things that are given to us in this problem. We know that our annual interest rate, R, is 4.5%. Written as a decimal, this is 0.045. The number of years we're interested in is 25 years, so our t is going to be 25. And the amount of money that we want in 25 years is $50,000. So this time our A, our future value, is $50,000. And what's unknown to us is our present value, or our principal. Since interest is compounded continuously in this problem, we're going to use our new compound interest formula, A equals P times e to the power of RT. Plugging in our values, we have 50,000 equals P times e to the 0.045 times 25. So if we want to solve for P, all we have to do is divide this number to the other side of the equation. So let's divide the left-hand side by e to the 0.045 times 25, and divide the right-hand side of the equation by the same thing. So our principal P is equal to 50,000 divided by e to the 0.045 times 25. Typing this into our calculators, we end up with P equals $16,232 and 62 cents if we round to 2 decimal places. So if we invest around $16,000 into our savings account now, 25 years from now, we'll have around $50,000. Let's look at one last example. Suppose you have $500 of unpaid credit card debt. And suppose that the credit card company charges 20% annual interest compounded continuously. If you do not make any payments, how long will it take for your balance to reach $5,000? Since interest for debt accumulates in the same way that it does when we put money in a savings account, we can use the compound interest formula to help us out. First, let's write down our given information. We know that the initial amount that we owe is $500, so our principal P is 500. The credit card company charges 20% annual interest, so our annual interest rate R is 20%, or in terms of a decimal, this is 0.2. We're interested in how long it takes for our balance to reach $5,000. So in this problem, our A is going to be 5,000. What we want to figure out in this problem is the amount of time it takes. So T is going to be our unknown quantity. Since interest is compounded continuously, we're going to use our new compound interest formula, A equals P times e to the power of R times T. Plugging in our values into this equation, we have 5,000 equals 500 times e to the power of 0.2 times t. Now all we have to do is solve this equation for t. So first we're going to divide both sides of this equation by 500. This leaves us with 10 equals e to the 0.2 times t. If we want to solve for t, we need to undo the exponential with base e. The inverse operation to that is the natural log. So let's take the natural log of both sides. On the left, we'll have ln of 10, and on the right, the ln and the e will cancel each other out, leaving us with just 0.2t. Lastly, if you want to get t by itself, we just have to divide both sides by 0.2. So in the end, we have t equals ln of 10 divided by 0.2. Typing this into our calculators, we have t equals 11.5 years. So if we start off with $500 in unpaid credit card debt, after 11.5 years, it'll reach $5,000. So in this video, we learned how to calculate future value, present value, and the time it takes to reach a certain amount of money if interest is compounded continuously.